Today we're doing section 11.1 and we're going to be starting an introductory to calculus. So the first idea that we're going to kind of discuss is the idea of a limit. So this graph to the left is a graph of the function x squared minus 4 over x minus 2. So if you imagine that these two people are walking towards one another, so notice the person on the bottom is traveling up and they're going to kind of fall off at this value of 4, and the person at the top is down traveling again and there's that open hole at 4, so they're both traveling to this y value of 4. Therefore we would say that the limit is approaching 4 because when I approach 2 from either side, the y value is 4, even though the value of 2 is undefined. So we're going to initially kind of look at it in a table form. So here we have, the way you kind of pronounce this is the limit as x approaches a of your function. So you're looking for what, as my x values get closer and closer to this value, what's happening to the y values is essentially what we're looking for. So for our first one, I have the limit as x approaches 4 of the function 3x squared. So what we're going to do is make a table out of this. And just like the idea of that very first picture we showed you, we're going to approach 4 from the left side and we're going to approach 4 from the right side to see what it's getting closer to. So using a calculator, we would type 4 times 3.99 squared. And when I do that, I get 47.76. Then we're going to plug in 3.99. So again, the idea of approaching means we're going to get very, very close to 4, but not actually use 4. So when I do that, I get 47.97. And then when I plug in 3.99999 in the calculator, I get 47.9976. So it's pretty safe to say that this is getting closer and closer to 48, but we have to make sure that happens from the other end of the spectrum. So above 4 getting smaller. So if I plug in a 4.01 to this, I get 48.24. Then we're going to test 4.001. And when I do that, I get 48.024. Then we'll check 44.0001. When I do that, I plug it in, I get 48.0024. So because from either side, as I approach 4 from the left side and I approach 4 from the right side, I can say that the limit is approaching the value of 48. So now let's try one with a trig function in it. So again, we'll use calculators for this. You need to make sure you're in radians when you're plugging in the value of 0. So we're going to approach 0 from the left side, we're going to approach 0 from the right side. So I have a negative 0.01. So when I plug that into the calculator in radians, I get 0.99985. Then I'll plug negative 0.02. And I get 0.99993. And a negative 0.03, I have 0.99998. So it appears like it's getting closer and closer to the value of 1. Now we have to approach 0 from the positive side. So when I plug in a 0.01, I get 0.99998. When I plug in a 0.02, I have 0.99993. And at 0.03, we get 0.99985. So because, again, from either direction, as I am approaching 0 from the left side and approaching 0 from the right side, it's clear that this limit is approaching the value of 1. The table is not something you necessarily would have to write down. We could use this in the calculator and look at the t-chart. If we didn't have a graphing calculator, then we would have to write this out. So next we're going to kind of approach the limits using graphs. So the idea is that in order for the limit to exist, it has to approach the same thing from the left side and the right side. So we check with the graph, we look, and it's possible that it could be a does not exist, but we'll kind of go through those different scenarios. So here, there's two scenarios. So let's go through the limit idea of the limit first. So an x value of 4, let me change this color. The x value of 4 is right here. So as my x values get closer to 4 from the left side, so I'm getting closer and closer, notice the y value is getting closer to 7. As I approach 4 from the left side, again, the y value is getting closer and closer to 7. So because it's approaching the same value from the left and the right side, the limit is approaching the value of 7. However, the second part of this problem is saying find f of 4. So we know that if I was finding f of 4, I go to where x is 4, and then I find its matching y value. So when x is 4, it's defined at this dot right here, and the y value for that is 2. So notice the limit, the actual value itself at 4 is not defined at 7, it's defined at 2, but the two values on either side are approaching the value of 7, so that's why the limit is 7. So the last thing that we're going to do is go through finding a limit by graphing. So going back to piecewise functions, f of x is equal to 2x minus 4 if x does not equal 3, and x equals negative, or y equals negative 5 if x equals 3. So I'm going to go ahead and make our t-chart. So remember, the way we did this is we made two t-charts. So for that top function, I can use any value except 3. Whereas the second t function, the second t-chart, the only x value I can use is negative 5. Or sorry, is 3. So for the bottom one, when x is 3, y is negative 5, and that's it. There's only one coordinate for that one. For the left one, I'm going to plug in these values. When I plug in 0, I get negative 4. When I plug 1 into this function here, 2 times 1 is 2, minus 4 is negative 2. 2 times 2 is 4, minus 4 is 0. 2 times 4 is 8, minus 4 is 4. 2 times 5 is 10, minus 4 is 6. 2 times 6 is 12, minus 4 is 8. Now again, you don't have to plot all these points once you get the general idea of what the picture looks like. That's plenty. So if we were to graph this, so at 3, negative 5, I'm actually going to move this over a little so we can see more of the picture. So at 3, negative 5, 1, 2, 3, 4, 5, we have a closed dot because it's where it's defined. The rest of the dots, so I have a 0, negative 4, a 1, negative 2, 2, 0, a 4, 4, and so on. Now, notice the only value that it is not defined at is at 3. So I'm going to plug in 3 here, just so I know where my open dot goes. So when I plug in 3, 2 times 3 is 6, 6 minus 4 is 2. However, this dot is open because it's not defined there. So at 3, 2, I have an open dot. But for the rest of the line, we have a very linear piece. Apparently I can't count because that one is definitely not at 4. 4 would be up there. There we go. So here we have this nice linear piece, and now we're going to answer 2 questions about it. So I'm going to erase these t-charts so I have room to write the question. So the question is, what is the limit as x approaches 3 for my function versus f of 3? So let's do f of 3. F of 3 is pretty easy, so when I go over to 3, the y value is that 2, 3, 4, negative 5. And again, I had issues counting. This should have been down here at a negative 5. Whereas the limit, so as I get closer and closer to 3 from the left side, it's approaching a y value of 2. And as I get approaching 3 from the right side, again I'm approaching a value of positive 2. So the limit as x approaches 3 is a positive 2. So we're going to do some more practice on this tomorrow.